Hello everyone, welcome to another episode of Matuto sa Siknayan Mga Nicolasian. I'm Mr. Robert De Guzman, your presenter in this week's video lesson in Statistics and Probability, Quarter 3, Week number 5. Let's take a look at the most essential learning competencies in this week's video lesson. The learner is able to A. Illustrates random sampling, B. Distinguishes between parameter and statistic. To begin, let's have a quick review. What is a population? A population consists of all subjects that are being studied. Ang subjects na tinutukoy sa population ay maaaring set of individuals or person o di kaya set of objects, places, or events na gagamitin para sa isang study o research. However, most of the time, due to the expense, time, size of population, medical concerns, etc., it is not possible to use the entire population for a statistical study. Therefore, gumagamit ang mga researcher ng sample. So what is a sample? A sample is a group of subjects selected from a population. Let's have an example. Kung ang population ng ating study o research ay lahat ng students sa senior high school in San Nicolas 3, ang ating magiging sample ay selected students in senior high school in San Nicolas 3. So maaaring lahat lang ng modular students o di kaya lahat lang ng online class students. Let's have another example. Identify the population and sample. A survey of 1,000 households in Bacoor City found that 18% of the households own a personal computer. Now let's define the population. The population in this case is all households in Bacoor City only. Hindi kasali yung mga households outside Bacoor City. Samantala, ang sample ay the 1,200 households surveyed. Another example, as of May 6, 2020, the Department of Health recorded 131,786 unique individuals who got tested for the COVID-19 out of approximately 109,369,019 Filipinos. So, alin dito ang population at alin dito ang sample? The population in this case ay all Filipinos na may approximate na bilang na 109,369,019. Ang tawag sa bilang na ito ay population size. On the other hand, ang sample ay lahat ng individuals who got tested for the COVID-19 na may kabuuang bilang na 131,786. Ito naman ang tinatawag na sample size. After mong ma-identify ang target population na gagamitin para sa iyong study o research, ang susunod mong kailangan gawin ay mag-identify ng iyong sample. Sino-sino ba ang kasama sa sample o gaano kadami ang nasa loob ng sample? Ito ang tinatawag nating sampling. Sampling is the act, process, or technique of selecting an appropriate sample size or a representative part of population for the purpose of determining the characteristics of the whole population. Sa sampling, ang makukuhang findings o conclusion from the sample is a general conclusion for the whole population. There are two types of sampling. First, the random sampling or the probability sampling. In this sampling technique, each element in the population has an equal chance of being included or selected in the sample. Ginagamit ang random sampling para maiwasan or mabawasan ang pagkakaroon ng bias. Second, we have the non-random sampling or the non-probability sampling. In this sampling technique, there is no random selection of data involved. Kadalasan, kung sino lamang ang available na respondents o participants ang magiging bahagi ng sample. Sa non-random sampling, hindi ganong concern ng researcher ang sampling bias. In this video lesson, pag-aaralan natin ang tungkol sa random sampling. May iba't ibang klase ng random sampling na ginagamit depende sa laki ng population o ang tinatawag na population size. Ang karaniwang ginagamit para sa average population size ay number 1, simple random sampling. A simple random sampling is a sampling technique in which every element of the population has equal probability of being selected for inclusion in the sample. Examples of simple random sampling are lottery sampling and using table of random numbers. One example of simple random sampling is the lottery sampling. Ano nga ba ang ibig sabihin ng lottery sampling? A lottery sampling is usually carried out by assigning numbers to each member of the population. Then place number cards in a bowl, mix them and select as many cards as needed. Another type of simple random sampling is using table of random numbers. Ang table of random numbers ay naglalaman ng series of 5-digit or 6-digit numbers arranged randomly in rows in columns. Kadalasan matatagpuan ito sa likuran ng mga statistics books at maaari na din itong ma-download sa internet. Let's try an example. A researcher wants to study the effects of social media on grade 11 students in San Nicolas High School. He wishes to use the simple random sampling technique in choosing members of his sample. If there are 1,000 grade 11 students in the school, how many students should be in his sample? In this problem, we need to determine first our sample size. Ilan bang grade 11 students ang kailangan out of the population na 1,000 grade 11 students na gagawing sample? To do that, we have to use the Slobin's formula. Use the Slobin's formula to determine the number of students that should be in the sample. Narito ang formula, where n, small letter n, is the number of samples needed, and capital N is the population size, and E is the margin of error, and usually this is 5% or 0.05. Let's compute the sample size of the given problem using Slobin's formula. So we have 1,000 population size divided by 1 plus 1,000 times 0.05 margin of error square equals 285.7 or 286 students. So this means that we need to select 286 students out of 1,000 grade 11 students to represent our sample. So how to select these 286 students using the lottery sampling and table of random numbers. So let's continue. Let's perform lottery sampling for example number 1. Step 1. Assign a number to each member of the population. Gumawa ng listahan ng 1,000 students katulad nito. Step 2. Write the numbers on pieces of paper with the same size and shape. Fold the pieces of paper. Gumawa ng hiwalay na numbers 1 to 1,000 at isulat sa kapirasong papel. At step 3, put all the folded pieces of paper in a bowl or box. Dahil ang sample size natin ay 286 students lang, so step 4, without looking, randomly pick 286 folded papers from the bowl or box. Lahat ng mapipiling numbers at corresponding students ang magre-represent ng sample. Subukan naman natin ang table of random numbers for example number 1. Step 1. The number of students is a 4-digit number, therefore assign a 4-digit number to each of the 1,000 students, katulad nito. Step 2. Randomly select a starting number from the table. And step 3. If the table of random number contains 5-digit numbers, consider only the last 4 digits since the total number of students in the population is 1,000, which is a 4-digit number. Let's have an illustration. Halimbawa, ang first random number natin ay 50267. Ang last 4 digit ay 0267. Or 267 is less than 1,000. So sa makatwid, ang 267 student in the list is the first member of the sample. Then, we're going to go to the next random number, pababa. Then we will have 11386. Ang last 4 digit niya ay 1386. This is greater than 1,000. So, this is not in the list. And go to the next random number, 10534. Ang last 4 digit niya ay 0534 or 534. Therefore, the 534th student in the list is the second member of the sample. Then, let's say the next random number is 20610. Then we have the last 4 digit is 610. And this is less than 1,000. Therefore, the 610th student in the list is the third member of the sample. Then we have 45217. So, the last 4 digit is 5217 and this is more than 1,000. So this is not in the list. So we're going to continue this until maabot natin ng 286 students na kailangan natin para sa sample. Another type of random sampling is the systematic random sampling. Systematic random sampling is a technique in which every kth element of the population is selected until the desired number or elements in the sample is obtained. The value of k is calculated by k equals capital N over small letter n, where k is the sample interval, capital N is the population size, and small letter n is the sample size. Let's have an example. In a group of 250 students, how will you select a sample containing 71 students by using the systematic sampling technique? Step 1. Assign each student a number from 1 to 250. Step 2. Find the sampling interval using the formula k equals 250, which is the population size, divided by 71, which is the sample size, equals 3.52, or round up to the nearest whole number, equals 4. Step number 3. So select a number from the whole numbers between 0 to k plus 1 by simple random technique. So in this case, the numbers between 0 and k plus 1 are 1, 2, 3, and 4. The chosen value is called the random start. So ibig sabihin, so yung numbers between 0 and k plus 1 ay 1, 2, 3, at 4. So pipili tayo dito sa pamagitan ng simple random technique using the lottery, at kung ano man ang mabubunot na number, that would be the random start. Step 4. Assume that the randomly selected number is 2. Use 2 as the starting number. Step 5. Select every fourth student from the sampling frame starting from the second student. Let's have an illustration. Halimbawa, ito yung number of students from 1 to 250. So magsisimula tayo sa second student. That will be the first member of the sample. Then we're going to get every fourth student. So simula sa 2, bibilang tayo ng 1, 2, 3, 4. The second member of the sample will be number 6. Then 1, 2, 3, 4. The third member of the sample will be number 10, and so on and so forth. So this is the systematic random sampling technique. Another type of random sampling is stratified random sampling. In stratified sampling, the population is partitioned into several subgroups called strata based on some characteristics like grade level, gender, age, ethnicity, etc. Then samples are randomly selected separately from each stratum. Sa stratified random sampling, inahati ang population into subgroups na tinatawag na strata. So for example, they are grouped according to age or according to gender or according to any other characteristics. Then, gamit ang simple random sampling, pipili ng mga representative sa bawat stratum at ito ang magiging members or elements of your sample. Let's have an example. Marcella, a statistics and probability class student, wants to determine who care more about their physical appearances, the male or female students. She wants to limit her study to the grade 10 students. There are unequal numbers of grade 10 students, 340 are male and 500 are female. She wants her sample to consist only of 50 students. She chooses the members using stratified sampling technique. Let's see the illustration. Step 1. Subdivide the grade 10 students into two subgroups according to gender. So let's take a look at the table. We have population and number of students per strata. We have male, 340 students, female, 500 students for a total of 840 students. Step 2. Divide the number of students per gender by the total number of students and multiply the resulting quotient by 50. So, for male, we will have 340 divided by 840 times 50 equals 20.24 or 20. For female, 500 divided by 840 times 50 equals 29.76 or 30. So therefore, our sample will be 20 males out of 340 and 30 females out of 500 to make a total of 50 students. Lastly, we have cluster random sampling. Cluster or area sampling is a random sampling technique in which the entire population is broken into small groups or clusters. So this is the same with stratified sampling. Hahatiin din ang population into groups na tatawaging clusters. Then, the researcher randomly selects some of these clusters and all of the elements or members from the selected clusters will make up the sample. So pagkatapos may group ang population into clusters, ang researcher ay pipili ng mga clusters sa pamamagitan ng simple random sampling. At lahat ng members or elements sa napiling cluster ay magiging parte na ng sample. Cluster sampling is used when the population is large and when it involves subjects residing in a large geographic area. Let's have an example. Suppose you want to conduct an election survey in Bacoor City dahil gusto mong malaman kung sino ang napupusuang kandidato ng mga taga Bacoor City. Pero hindi lahat ng taga Bacoor ay kasali sa survey dahil ang target population natin ay only registered voters in Bacoor City. Paano ito gagawin? Step number 1, divide the population into clusters. Hatiin ang Bacoor City into clusters. In this case, ang barangay ang magiging clusters. Then, step number 2, choose 1 or up to 3 barangays using simple random sampling. Mayroong 73 barangays ang Bacoor City, so pipili lang tayo ng isa o hanggang 3 barangay using simple random sampling. Assume that the randomly selected barangay is San Nicolas 3. So step number 3, all registered voters in San Nicolas 3 will be surveyed dahil lahat ng members sa napiling cluster will be part of the sample. Now let's move to the non-random sampling or non-probability sampling. There are two types of non-random sampling. First, convenience sampling. In this technique, the researcher gathers data from nearby sources of information exerting minimal effort. Convenience is being used by persons giving questionnaires on the streets to ask the passers-by. Halimbawa din nito yung mga nagsasagawa ng survey sa loob ng mga malls. Then, we have purposive sampling. In this technique, the respondents are being selected based on the goal of the studies of the researcher. For example, if the study is about the students who are children of OFW, the researcher will get samples who are children of OFW. This excludes other students from being a sample. Our next topic is computing for the parameter and statistic. What is the difference between parameter and statistic? A parameter is a measure that is used to describe the population, while a statistic is a measure that is used to describe the sample. Parameters are usually denoted by Greek letters. Population mean, population variance, and population standard deviation are examples of parameters. Statistics are usually denoted by Roman letters. Examples of statistics are sample mean, sample variance, and sample standard deviation. Let's recall the meaning of a mean. The mean is the sum of the data divided by the number of data. The mean is used to describe where the set of data tends to concentrate at a certain point. When we say population mean, it is the mean that is computed based on the elements of the population. The symbol, read as mu, is used to represent population mean. To compute for the population mean, we simply add all the data, denoted by x, and then divide it by the number of elements in the population, denoted by capital N. So we apply the formula, the summation of x divided by n, where mu is the population mean. Summation of x is the sum of all the given data in the population, and n is the number of elements in the population. On the other hand, variance and standard deviation determine how to spread or to scatter each data on the set from the mean. Standard deviation is simply the square root of the variance. To compute for the population variance, we apply the formula sigma square equals x minus u square divided by n, where x is the given data, mu is the population mean, and n is the number of elements in the population. To compute for the population standard deviation, we apply the formula sigma equals square root of x minus mu square divided by n, where x is the given data, mu is the population mean, and n is the number of elements in the population. As you can see, the formula in standard deviation is simply just we take the square root of the variance to find the standard deviation. Let's have an example. The third quarter grades in statistics of 10 students are the following. Treating this data as population, find the following: A. Population mean, B. Population variance, and C. Population standard deviation. First, let's summarize or arrange our data using table. So we will have something like this. As you can see, we have 10 students, so that our n equals 10, or the number of elements in the population is 10. And these are the corresponding grades. We're going to add all of these grades so that we will have the summation of x equals 840. Now, to compute for the population mean, we have the formula, the summation of x divided by n. So substitute the values. We have 840 divided by 10 equals 84. Therefore, the population mean is 84. This time, we're going to compute the population variance and the population standard deviation. To do this, we should have known the population mean. Dapat alam na natin ang computed population mean at this point. So let's review our table of data. In the first column, we have the students' number. There are 10 students, so that our n is equal to 10. The next column is the corresponding student's grade, and the sum is 840, so that our population mean is 84. To compute for the population variance and population standard deviation, we have to subtract each given score or data from the population mean, and we will square the result. In symbols, we have x minus mu, the population mean, and x minus mu square. For example, in our first data is 94 minus 84 equals 10, and 10 square is 100. Then 85 minus 84 is 1, and 1 square is still 1. 88 minus 84 is 4, and 4 square is 16. 79 minus 84 is negative 5, and negative 5 square is 25. Then 78 minus 84 is negative 6, negative 6 square is 36. We're going to repeat the same process for the rest of the data, and we will have these answers. After that, we're going to get the sum of all values in the last column, and the sum is 382. So we can now compute for the population variance, and the formula is, then let's substitute the values. We have 382 divided by 10, and the computed population variance is 38.2. Now to compute the population standard deviation, we have the formula. So let's substitute the values. We have square root of 382 divided by 10, or just simply square root of our computed population variance 38.2, and we have 6.18. The computed population standard deviation is 6.18. Now let's move to the sample mean. Sample mean is the average of all values randomly selected from the population. The symbol read as X bar is used to represent the sample mean. To compute for the sample mean, we simply add all the data and then divide it by the number of elements in the sample, denoted by small letter n. We apply the formula. X bar equals the summation of x divided by small letter n, where x bar is the sample mean, the summation of x is the sum of the given data, and n is the number of elements in the sample. Sample variance is the computed variance of the elements of the sample. S square is used to represent sample variance. To compute for the sample variance, we apply the formula. S square is equal to the summation of x minus x bar square divided by n, where x is the given data, x bar is the sample mean, and n is the number of elements in the sample. And sample standard deviation is the computed standard deviation of the elements of the sample. S is used to represent sample standard deviation. To compute for the sample standard deviation, we apply the formula. S is equal to the square root of the summation of x minus x bar square divided by n minus 1, where x is the given data, x bar is the sample mean, and n is the number of elements in the sample. Let's have an example. The following are ages of the 16 math teachers at Archimedes Secondary School. Assume that a researcher randomly selected only 8 out of the 16 math teachers. Compute their A. Sample mean, B. Sample variance, and C. Sample standard deviation. Assume that the encircled data are those that were randomly selected. So the first thing we will do is to prepare a table for our sample data. So we have teacher 1, 2, 3, 4, 5, 6, 7, 8. So our n is 8 and their corresponding age. And the sum of the ages is 276. We can now compute for the sample mean. The formula is, so we have to substitute the values. 276 divided by 8 equals 34.5. The computed sample mean is 34.5. So this mean is no longer the population mean because the data used is no longer consisting of the entire population. This time we're going to compute the sample variance and sample standard deviation. This process is similar with computing the population variance and computing the population standard deviation. So here, we should have known the sample mean. Dapat alam na natin ang sample mean. So let's review our data once again. So we have teachers 1 to 8, so that our n is equal to 8 and their corresponding age, and the sum of their ages is 276, so that our sample mean is 34.5. Now to compute for the sample variance and sample standard deviation, we need to subtract its score or data from the sample mean. Then the result is we're going to square the result. So we will have something like this. So 34 minus sample mean 34.5 equals negative 0.5. So 32 minus 34.5 equals negative 2.5. Then after we subtract its score from the sample mean, so we're going to square the result, and these are the values. And negative 0.5 square is 0.25. Negative 2.5 square is equal to 6.25. Then get the sum. So the sum is equal to 42. So at this point, we can now compute for the sample variance. So the formula is this. So we have to substitute the values. 42 divided by 8 equals 5.25. And to compute for the standard deviation, we have this formula and substitute the square root of 42 divided by 8, or just simply the square root of the variance, which is 5.25, and the result is 2.29. So our computed sample variance is 5.25 and our computed standard deviation, sample standard deviation is 2.29. That's the end of my presentation. I hope you have learned something from this video lesson, and do not forget to fill out the survey or evaluation form about this video. Thank you and have a good day.